Hi, I'm Cassie, and I'm going to walk you through question 49 of the AAMC's official physics question pack to help you prep for the MCAT. So this is the first question related to passage 8 of the question pack, and it's all about understanding mirrors. So let's break it down. We want to know what's going to change the focal length of a convex mirror. So first of all, what is the focal length of a mirror? The focal length of the mirror is just going to be the distance from the focal point of the mirror. So what is the focal point of a mirror anyways? Well, remember that the main difference between mirrors and lenses is that mirrors reflect light, so light rays hit them and bounce off, reflect back. And lenses, think of like contact lenses, they let light through, right? That's important, otherwise the light wouldn't be able to get into your eyes for people that need contacts. Okay, so the focal point for a mirror, which we said reflects light, is going to be the point at which rays that go parallel to the axis of the mirror hit the mirror and then actually converge in the case of a concave mirror, or appear to converge in the case of a convex mirror. So what I mean by that is with our concave mirror here, which goes inwards like a cave goes inwards, this is our principal axis in the middle here. And then if we draw our ray diagrams, so we're going to draw a ray that goes parallel to our principal axis, notice that it hits our concave mirror and it seems to bounce back and hit this focal point here. And the same thing happens if you take a ray from another angle. All the rays are going to converge at this focal point here. So then the focal length is just the distance from the mirror to this focal point. So that would be the focal length here. Now, this question is specifically asking about a convex mirror. So in a convex mirror, we do the same thing. We have our principal axis here that our mirror is on, and then we're going to go ahead and draw our rays that are parallel to our principal axis. And notice they hit the mirror and they're going to bounce back. And so what we have to do here is basically project those rays backwards. So again, they're going to hit the mirror and bounce back. So we project the rays backward, and then we find our focal point for our convex mirrors is actually behind the mirror. So those rays appear to be converging behind the mirror. So our focal length here would be, again, from the mirror to our focal point here. But having reviewed those concepts, I would have started off this question by just drawing my own simple diagram. So here is my convex lens, and so I know that my focal point is going to be behind my convex lens. And then we have to define a couple other important terms to know when we're talking about mirrors and lenses. One of those is our center of curvature. Our center of curvature is just equal to 2 times our focal length. So again, if this is our focal point, then this is going to be our focal length from here to here. And our center of curvature is just 2 times that distance. And then the other quantity we need to know is our radius of curvature, which as it sounds is just the radius or the distance from our mirror to our center of curvature. So now that we've got our key kind of terms down here, let's go ahead and take a look at our answer choices. Again, we want to know what's going to change the focal length of our convex mirror here. Well, immediately the answer choice that jumps out to me is changing the radius of curvature of the mirror. Why is that? Well, if we change our radius of curvature, let's say we make our radius of curvature longer. So now this is R. Well, we said that the radius of curvature is the distance to our center of curvature. So now instead of our C being here, it's going to be over here. And we said our C is 2 times our F. So now instead of our F being here, it's got to be farther over here. So we had to change our F if we change our C, because the two are related by this equation where the center of curvature is just twice our focal length. So the correct answer is going to be, it looks like answer choice B for me, which is the radius of curvature of the mirror. Now, why are the other answer choices wrong? Well, choice A for me talks about changing the index of refraction of the mirror. So when we talk about index of refraction, we're usually talking about Snell's law. Index of refraction is a property of a certain medium. Like, for example, water has a certain index of refraction and air has a certain index of refraction that just represents when light passes into it, how much that light is going to bend. So we know, according to Snell's law, that when light goes from a less dense medium like air into a more dense medium like water, it's going to bend, and specifically it's going to bend towards that normal, that perpendicular line to our surface. So we're dealing with mirrors here. We're not talking about different mediums. We talked about the fact that mirrors, what they do is they reflect things. They don't refract things. Lenses refract things, right? Think about when light comes into your eye, the lens of your eye is going to bend that light a little bit. So answer choice A about changing the index of refraction is wrong for multiple reasons. We're talking about mirrors, we're not talking about different mediums, and we know that mirrors reflect, whereas lenses refract. Okay, so that's why that answer choice is wrong. If we take a look at answer choice C for me, it says changing the position of the lens at B. In other words, what if we moved the lens from where it is here on our axis over to the right? Or we could even move it over to the left. Is that going to change our focal length? No, our focal length is still going to be the exact same distance as it was here, because the focal length is a property of our mirror, or it doesn't depend on where our mirror is on the axis. And the last answer choice that is wrong is changing the focal length of the lens at B. So the lens is separate from the mirror. So changing something about the lens isn't going to change something about the mirror. They're two separate things. So that's why that answer choice is wrong. So I hope this helps. If this helps, please leave a like and feel free to drop any comments if you have any questions. Follow my channel for more content like this.